Hey guys, so I am going to go through some notes and some example problems that should help you get through the percent composition and molecular formula worksheet. Okay, so in the last video I talked about how to calculate the empirical formula and a little bit about what the empirical formula is. Just to review, so you have molecular formulas and you have empirical formulas. Your molecular formula is your true formula. Like, if I were to go and look at that molecule, this is what it would present as. So our example of that is C6H12O6. Okay, so that is the molecular formula for a molecule of sugar. Okay, now your empirical formula is your reduced or your lowest ratio. So we can see over here that if we take these numbers and reduce them all down, we're going to end up with this. So this is our ratio. For every carbon, we have an oxygen, and for every carbon, we have 2 hydrogens. Okay, so this is your empirical, this is your molecular. Now in the last video, we found empirical formulas. Today we are going to find molecular formulas, okay? So, just like in the last one, we have some steps. Your first step is going to be to find the mass of the empirical formula. So, you are going to find your empirical formula, or be given your empirical formula, and then you're just going to find the mass of that, okay? And that's super easy because in this case, you literally just take carbon's mass plus 2 hydrogens plus an oxygen, okay? Then we are going to take the mass of the molecular formula and divide that by the mass of the empirical formula. So in this case, all of these worksheets give you the mass of your true molecular formula, okay? So we'll take that mass that we just found, and we'll take our molecular formula and divide it by the empirical we just found. And that will give us our ratio. So then you will take that ratio and you will multiply your empirical formula by that ratio to get your molecular formula. So let me give you some examples as to what this looks like. So let's say that we have an empirical formula of P2O5. And our molecular formula, the true mass, is 283.88 grams. Okay, so our first step is going to be to find the mass of this empirical formula. Okay, so I'm going to grab my periodic table out, and I'm going to add the mass of this phosphorus, which is 30.97, and there's 2 of them. Okay, and 5 of these oxygens. Okay, so when I put that in my calculator, I'm going to get 141.94 grams. So this is the mass of my empirical formula. Okay, then I'm going to take the molecular formula that I was given in the problem, and I'm going to divide that by this mass that I just found. Okay, and so putting that into my calculator, it's going to give me around 2. I'm going to punch that in real quick just to get my, oh, it's exactly 2. Okay, well, there we go. So it's going to be 2. So then I'm going to take this ratio that I just found and use that to solve for my actual formula. So if my original empirical formula is P2O5, I'm basically going to double everything. So my true formula is P4O10. Okay, and so that is how you use empirical formulas to find molecular formulas. So let's do another example, maybe one that's a little more challenging. So let's say that our problem gave us some percentages. So we have 71.65% chlorine. We have 24.27% carbon. And we've got 4.07% hydrogen. And so we have a sample. These are our percentages. And our molecular formula weight in grams is, or mass in grams rather, is 98.96. Okay, so our first step is we are going to find our empirical formula. So just like yesterday, if I have these values, it may have been yesterday. Ooh, yesterday and the day before. Neat. Okay, so if these are my values, I don't necessarily know how much the original sample weighs, but I know that this percentages, these are going to have a ratio that is equal no matter how much sample you have. So I'm just going to say that instead of percents, these are all grams. Okay, because I'm just going to pretend like I have a 100-gram sample. All right, so I'm going to take chlorine, carbon, and hydrogen. I've got 71.65, I've got 24.27, and I've got 4.07. And then I'm going to divide that by the individual masses. So my chlorine, I know looking at my table, is 35.45. My carbon is 12.01, and my hydrogen is 1.01. So when I plug all that into my calculator, I'm going to get roughly 2.02 moles here. I'm going to get roughly 2.02 moles here, and I'm going to roughly get 4.03 moles here. Okay, so I'm going to take my smallest amount, which, I mean, these two are the same, so I'm just going to pick that one. And I'm going to divide all of them by that molar amount. So my chlorine is going to be 2.02 divided by 2.02, which is going to give me 1. My carbon, same thing, 2.02 divided by 2.02, which will be 1. And then my hydrogen, which is 4.03 divided by 2.02, which is going to roughly give me 2. Okay, so then I'm going to use these values to write out my empirical formula. So I've got 1 Cl, I've got 1 C, and I've got 2 H's. So this is my empirical formula. Okay, but I wasn't asked for the empirical formula. I was asked for the molecular formula. Okay, so using the new stuff, I can take this right here and this right here, up here, and find that empirical formula, or that molecular formula rather. Okay, so now I'm going to do step number 1 that we talked about today, and I'm going to find the mass of my empirical formula. Okay, so I've got Cl, which is 35.45. I've got 1 carbon, which is 12.01, and I've got 2 hydrogens, so 1.01 times 2. Okay, now if I plug that into my calculator, I'm going to get 49.48 grams. So that is how much this empirical sample weighs. Okay, then I'm going to use this amount and this amount to find my ratio. So I'm going to take my molecular formula, which is 98.96 grams, and I'm going to divide that by my empirical formula. Okay, and when you plug that into the calculator, you're going to get, I think, exactly 2. So then step number 3, I'm going to take this ratio that I just found, and I'm going to multiply it by my original, or by the empirical formula that I found. So if my original one that I found is that, I'm just going to double everything. So my new formula is Cl2, C2, H4. And that is my molecular formula. So hopefully this helps a little bit with your assignment today. If you have any questions, please email me or Dr. Howard or Ms. Watson and let us know. And I will see you guys in the next video. Bye.